All right, hello everyone, and welcome to another video on closed loop transfer function. So this was actually submitted by a subscriber, and I thought it's a good example on finding closed loop transfer function. I do have a lot of problems solved in the control system playlist, but I guess the more it doesn't hurt really. The more problem you solve, the better, until you get used to it. So here we have an ideal PID controller. CS function which is given, and then the plant negative feedback, and the feedback transfer function is given as h of s. And the question here is one of the questions actually is to find the closed loop transfer function. But I think any other questions after this, once you find a transfer function, is going to be really easy. So just make sure you understand the logic and how to get to the transfer function. So first you have to visualize, I guess, what's going on, and draw the circuit. Once you draw the circuit, you'll be able to see what's each function, and then you'll be able to derive the transfer function a lot more easier than just reading words here. So typically what we have here is you would have an input, right? Input signal. So, and in this case, I'm not going to go into, definitions and theoretical stuff on, PID controllers and how they work and whatnot. We'll just focus on solving the problem. So you have the controller controls a plant, and you have the negative feedback function here is closed loop back to input. So here we have an input function. We can call this whatever, RS. This is the negative feedback path. So the function is h of s. It's also given. And this is the controller, C of s, which is given. And this is P of s. That's the plant. And then you have the output. Let's call that y of s. So from here, you can just derive. This is what the question is asking at T of s. Ultimately, this is what we need. The transfer function is the output over the input. So that's y of s over r of s. And you can name these whatever letter you want. Doesn't matter. So this is what they're asking us to find from this diagram right here. So reading this is probably not going to help. But if you look at this, it's a lot easier when you look at it from here, from this diagram, to be able to, derive these functions right here. So we can start with just calculating. What I like to do is just naming, the immediate outputs or whatever. So this is the error functions coming out of the input. So typically E of s is, and since this is a negative feedback, we'll have R of s, the input, minus, this right here. Okay, so E of s is equal to R of s. Just like a summation, right? Just like a summation, but because it's a negative feedback, you'll have to subtract. So it's R of s minus y of s h of s. So I always start from there, and then I write down what my output is. So y of s here is this line over here, all of these multiplied together. So E of s times E of s times P of s. E of s, C of s times P of s. Now we can just replace E of s by its value. So y of s is E of s is equal to this right here. So that's R of s minus y of s, h of s. So this is your E of S, right, over here. So the whole thing is multiplied by CSPS, all right? So from here on, really, is just math and simplifications and, you know, plug and play, etc. So we'll just simplify this. So y of s. So we'll multiply out. So this is rs multiplied by cs ps, you know, simple algebra, minus ys hs cs ps, right? So you multiply rs by cs ps and multiply this right here ys hh by cs ps. Okay, so we need to take out the output, right? So put the outputs together. So, and a lot of these problems are almost the same, you know, they start the same, and then so once you get a hand of it, you know, you'll be able to pretty much sleep and solve the problem. So y of s is 1 plus, you know, you're bringing this together because you're taking out y of s. So this is just map, right? And so that's you take out y of s, which in this case you'll have a 1 left here, and then whatever is left here is h of s c s p s, and then this is equal to rs cs ps. And remember, what do we need? We need y of s over rs, right? So we'll have y of s over rs. So if I divide y of s, if I divide y of s by r of s, what am I left with? So this will give me c of s ps over 1 over h s cs ps. So this is the transfer function right here. So we can put that down here, t of s. So all we need to do from here is just replace the values. I think we are given everything here. We're given cs, ps. So in the problem here, it says one of the PID controllers, 0, is used to cancel the plant's pole at s minus 1, such that cs, ps is this function right here. So we just need to replace CSPS by this right here. And then h of s is 1 over s plus 10. So let's go ahead and plug and play. So this is, so CSPS is s plus wz over s, if I remember correctly, p0 over, I'll verify this afterwards. I think, what was it? Oh, s minus 5 instead of s plus 5. So let me erase that. So that's s minus 5. CSPS 1 plus h of s is 1 over s plus 10 times CSPS, which is, this is multiplied by, so let's just do this, s plus wz times p over s minus 5. So from here on is just, again, like I said, math. So let's take care of the top, and then we'll take care of the bottom afterwards. So here we have, let's start with P0, S plus Z over, so all I'm just doing is just multiplying these two together. So S s minus 5. And then the bottom is 1 plus this is P0, by the way. So we have P0 S plus WZ over S minus 5 S plus 10. So I just rewrite. I'm just rewriting this equation right here, just multiplying the top and multiplying the bottom. So this is equal P0 S plus WZ over S minus 5 S minus 5 S plus 10 plus P0 S and over S minus 5 S plus 10. Okay, so TS is now P0 S WZ over S minus 5 times S minus 5 S plus 10 over S minus 5 S plus 10 plus P0 S WZ or omega Z, whatever. So at this point, we can cancel these out. And the whole thing is now PS over S minus 5 S plus 10 plus P0 S. And you can even go further. I'm going to stop here, but you can go further to multiply out the denominator, because that's what you're going to need to find you know, system stability or any other subsequent questions after this. But pretend, you know, you can say, you know, S squared minus S5, you know, just kind of multiply these out so that the bottom will be, you know, S squared S plus S, whatever it is. And then from there, you know, you set your equations equal to 0 for just finding your poles and your zeros, you know, finding stability. But this is pretty much the baseline, right? So any questions from here will be really easy to find